Hi, welcome to week 4. This is lecture 1, and this is going to be our environmental lecture for the week. It is on melting ice, rising temperatures, and food security. When we, in the first week, talked about the scientific method and the methods of evaluating, here's what we see is happening, here's how we take the data, here's how we analyze the data so we can see if we have correlations that are reproducible, and then we come up and we have a theory or a hypothesis. This week we're going to look at the melting of glaciers, ice shelves, and continental ice sheets. And we're going to look at the data historically for at least the last 100 years, and we're going to look at the retreater growth compared to carbon dioxide in the atmosphere, combined with the temperatures that we see as well as the oceanic temperatures. We're going to take that data and we're going to apply the scientific method to it to see if we can draw a conclusion as to the advance or retreat of the ice, and see if we can make a connection with the physical science factors that we see. So that's your assignment about melting glaciers. Let me tell you first of all what a glacier is. A glacier is, excuse me, an ice field that has become so thick that it actually begins to flow under gravity. So the movement of flow under gravity is what defines a glacier. A continental ice sheet, such as we see in Antarctica or we see in Greenland, is one that you have snow and it's compacted down to ice, but it's not flowing. It may be expanding because it's growing larger, but it's not actually flowing. And then sea ice is the free-floating ice that we see, for example, off of Antarctica. It's not attached to land at all underneath. So you're going to pick one of those three and you're going to use it excuse me, to perform your scientific method analysis this week to draw your conclusions. Now, with ice melting, whether it's sea ice, glacial ice, or continental ice sheets, you have multiple factors that can affect the world. The first is the fact that if you have enough ice melt, then you are going to have a rise in mean global sea level. So the amount of ice that melts is going to provide an average over how much sea level is going to rise over the world. A big factor of melting glaciers is a lot of these are, of course, in the mountains, but they are the water sources for a lot of rivers. So for example, in the Himalayas, you have the Ganges Glacier, and it is what feeds the Ganges River in India. And as it melts, in the spring, it brings water that can then be diverted for irrigation and other purposes. As the glacier melts, there's going to be less water available to melt each spring, and you're going to have less of a flow of water into the Ganges river basin, where about 400 million people live. So the loss of water that's coming in every year is going to affect the people's livelihoods in that area. So that's the second way that melting glaciers, sea ice, ice sheets can affect excuse me, the world. The third is that as ice melts, let me tell you about albedo. Albedo is when the sun's radiation, long-wave radiation, sunlight comes in and it hits the earth. If it hits something that's a light-colored surface, it's going to bounce back. If it comes in and it hits something that's a dark-colored surface, it's going to absorb. And have you ever been on asphalt or a dark sidewalk in the middle of summer? Then you know that that dark surface is excuse me, absorbing the heat that is coming down. So it's taking that energy, and sometimes in the middle of cities you'll get these urban heat islands where the temperature in the city can be 20 degrees hotter than it is 100 miles away in the country. Well, if there's ice or snow, then the light and the energy are reflected back out into the atmosphere. If you have larger surface of ocean, which is darker, it absorbs even more of the heat that and the light that are coming in. So in turn, it's making an effect where you actually have warming waters, you have warming heat islands, and when you're melting glaciers, it's kind of a feedback loop. On the other hand, back in the Permian, they have the Earth was called Snowball Earth. There was a huge drop in temperature, and ice was allowed to build up. And the more the ice and the snow built up, the more light and heat that were reflected back, and it became a negative feedback loop. So eventually, they think that most of the Earth's surface was covered in ice because of albedo contributing to the fact that the light and the radiation was getting bounced back. Well, now we're in a part where we are in interglacial, if you remember that from our first week. So we've gone through glaciation, and now we're in interglacial, and then we can go back